Okay, so this is the first chapter. Its name is basically rocks and their extraction. So the first pointer that we will be covering is types of rocks, extraction of rocks and minerals from Earth. So as you can see, the Earth consists of three main layers. We have the crust, and we have the mantle, and we have the core. And crust is the outermost layer, mantle is the layer after that, and then the innermost layer is the core. Okay, then if you ask about the importance of crust, the importance is basically that it's made up of great variety of rocks, which means that people can use it for building stone, for energy supplies, for minerals, for metals, right? And then most of the land has a surface covering of soil, and soil, is the loose material in which plants grow, right? So that's again a very important factor, that we have the idea of mineral extraction and we have the idea of both agriculture. So that is why crust is very important to us. Then we have the idea of weathering and erosion. So, weathering and erosion are two geological processes that are going to break down a rock, but they both are different in terms of one thing, that erosion is going to make that weathered rock move also, while weathering occurs at a stationary place, right? So, when the smaller rock pieces, now pebbles, sand, and soil, are moved by these natural forces, it is going to be called erosion. However, if it is just changed or broken but stays where it is, then it is called weathering. Okay, so you have two simpler processes, simple geological processes, which involves the breakdown of the parent rock, and that is weathering and erosion. And you can have weathering in terms of many things. You can have it in physical, chemical, or biological. For example, if I talk about physical, then that's not in your syllabus. I'm just giving you a little insight into what it actually means. For example, if you talk about physical, our water, it may get into the cracks and rocks, and then when it freezes, it expands and it breaks down the rocks. Okay, so that is a form of physical weathering. Okay, so it occurs like this. Chemical, you may have in the form of our um, acid rain, and then biological, again, you can have in the form of decomposers, all these things. Okay, now this is something that is a very important part of our syllabus. This is the rock cycle. Okay, so what happens is, of course, if you want to start with, we know that weathering and erosion are going to be processes that are going to work hand in hand for this rock cycle to continue, because we have the idea that weathering is just breaking down the parent rock at one stationary place. However, erosion is the process that is responsible for moving that broken down rock. Okay, so it's gonna move. First of all, we have weathering simple, then we have erosion, and then that weathered and eroded material is going to settle on the seabed, where it's going to be compacted into rock, because we have the idea that it's going to get compressed by the accumulation of sediments. And then we have the building of mountains by the process of upfolding, and by the phenomenon of upfolding. And upfolding is basically going to occur in a specific type of plate movement that we call destructive plate movement, and that was in our chapter 9 of natural hazards, chapter 6, sorry. Now that's all about rock cycle. We have the idea that first step is weathering, second step is erosion, third step is simple compaction into rock, and then the fourth step is simple upfolding to build tall mountains. Examples are Himalayas, Andes. Okay, now moving on to the right types of rocks. We have three types of rocks in our syllabus. We have igneous rock, we have sedimentary rock, and we have metamorphic rock. So if we talk about a summary, here is a summary table in front of you. So igneous rocks are going to be rocks that are formed by fire. In our syllabus, we have two igneous rocks. We have granite and basalt. If we talk about sedimentary rocks, if you talk about how they're generally formed by the compression, accumulation, and compression of sediments. And examples include sandstone, clay, and shale. Metamorphic is basically metamorphic rocks are existing igneous or sedimentary rocks which are transformed by heat and pressure in the Earth's crust. An example is marble and slate. Marble is being formed from limestone, and slate is being formed by clay. And as you can see, they're both being formed, they're both a result, an outcome of the transformation of existing sedimentary rocks. Okay, so this is the idea of metamorphism or transformation, and then thus the idea of metamorphic rocks. Then this was a general overview onto how rocks are formed. Now, if you move on, you also have specific ideas onto how rocks are being formed. So if you talk about granite, definitely if they will ask you by name, that describe the formation of granite or describe the formation of basalt, sandstone, glacial. They can ask from any about any of these because they have included it in syllabus, right? So granite is formed from magma forced into rocks during the formation of fold mountains along destructive plate boundaries. So you need to remember the idea that granite is being formed by destructive plate boundaries and basalt is being formed by constructive plate boundaries. Now, one tip I used to remember it is at simply, that they're both being formed by different types of plate boundaries. So if we talk about basalt, you know that C comes after B, right? So just remember it that way, that BC, which means that basalt is being formed by constructive plate boundaries, okay? So just remember that fact. And then another thing is that you can see that granite is being formed from magma, which is the idea that it is underground. But if we talk about basalt, it is being formed from lava, okay? Which means that magma has come up to the surface, right? Then a little insight into chapter 6 again, because you have the idea of destructive plate boundaries and constructive plate boundaries already introduced here. So I added this thing here. Okay, so as you can see, if we talk about constructive, we have three main types of plate movements. You have constructive, you have destructive, and you have conservative. So if you talk about the idea of constructive, it's basically the movement of plates apart from each other, okay? And because of that, a gap is going to be formed, right? And from that gap, lava is going to flow out in a non-violent way. And again, we're talking about constructive, so we have the formation of basalt, right? And then also we need to remember this is something really important, that it's going to form volcanoes with wide bases and gentle sides, okay? So you may be shown the photograph of a mountain and they may ask you that from what type of plate movement is it formed. So you have to see that if it's a tall steep sided cone, then it's going to be destructive plate movement. But if you can see a volcano with wide bases and gentle sides, then it's going to be the idea of constructive plate movement, right? And then another feature formed by this type of plate movement is rift valleys. Rift valleys are basically those type of valleys which you see which are formed by the displacement of whole pieces of large pieces of rock, okay? So those are rift valleys. These are two features that are being formed by constructive plate movement. Then if you move on to destructive plate movement, now this is a little detailed plate movement which you need to know about. So first of all, you have, okay, here if you can see, both of them are what type of plates. We know that if we talk about the structure of earth, we have 70% water and 30% land, okay? So we have the idea of two types of plates. We have continental plate and we have oceanic plate, right? So here we had two continental plates, however here we have an oceanic plate and a continental plate, okay? So if you talk about destructive plate movement, we have an oceanic plate and we have a continental plate. They're going to both move towards each other and they're going to collide. And one of the plates, which is usually the oceanic plate, is going to get destroyed in the subduction zone. If we talk about what a subduction zone is, subduction zone is basically zone where one plate is getting destroyed because of the immense heat produced. And also because of this immense heat, sediments on the seabed are also going to get compressed and folded to form high mountain ranges, and you have some examples here. Okay, so this is all about destructive plate movement. And then also you have the idea that if we talk about constructive plate movement, volcanoes are being formed by lava that is flowing out in a non-violent way, right? But if we talk about destructive, two plates are colliding, right? So it's gonna be really violent, okay? And then you have the idea of tall steep sided cones as well. And then earthquakes are also frequent in this type of plate movement, okay? Then moving on, we have, so this was all about our igneous rocks. Now we have the idea of specific formations of sedimentary rocks. So again, if you talk generally of how sedimentary rocks are formed, they're simply formed by the accumulation and compression of sediments. Okay, but if we talk about clay and shale, they're specifically being formed by accumulation and compression of mud. If we talk about limestone, it's specifically being formed by masses of shells of sea creatures accumulating on the seabed and then eventually getting decomposed over a long period of time to form oil and gas. Okay, and then as you can see, this thing is the idea of metamorphic rocks. Now, again, as you can see, you don't really have a lot of points written for if somebody asks you how marble is formed or how slate is formed. So you're gonna get 1 mark for writing that slate is being formed, or you can say slate is a metamorphic rock of the sedimentary rock clay, or marble is the metamorphic rock of the sedimentary rock limestone. But you're going to get the second point on writing that it is transformed by heat and pressure in the earth's crust. Okay, So this is the simple idea. Now we have two different types of rocks being shown here as well. You can see that these are basalt cliffs in Iceland and these are limestone cliffs. So we have the simple idea that if we talk about the accumulation of masses of Dead Sea creatures, they're going to accumulate horizontally, right? So the lines of weaknesses here are horizontal, and because lava is going to flow out in a vertical way, so you have the idea that lines of weaknesses are vertical. So just a simple picture to enhance your knowledge, not really important for your syllabus. Okay, now moving on, if we talk about extraction of rocks and minerals from Earth, you have two types of mining. You have surface mining and you have subsurface mining. All right, so and then you have the second factor, second pointer of syllabus that you need to know about the factors affect the decision to extract rocks and minerals. So again, as you can see, according to the papers that we have done till now, we see that not a lot of questions are asked from deep inside somewhere, okay, or test your knowledge. Just simply test the simple pointers of syllabus, right? So if you know it on your fingertips, that if you're talking about factors, you're talking about exploration, geology, accessibility, environmental impact assessment, supply and demand, you can simply attain marks on the fact that you're quoting what's written in the syllabus, okay? Now, if we talk about open cast mining, we can compare it with quarrying, okay? Because open cast mining is the idea that you're extracting minerals. However, quarrying is the idea that you're extracting rock. The similarity is that both are going to have the same procedure, and they both are going to extract either rock or mineral from the surface. They're both going to leave a large hole in the ground. Then, if we talk about several other terms for open cast mining, we have open cut mining, strip mining, you have open pit mining, okay? And then methods, again, you need to know it in chronological order. You need to write it as it's written here, okay? So, and again, all of the content here, if you study through it, it's gonna be enough, okay? So if you see, first of all, definitely if you're talking about open cast mining, you're talking about extracting something from the surface, right? So you're going to clear the vegetation. That's going to be the first step. Then the major difference between open cast and deep mining is that you're using explosives to break down the rock, okay? And once you have broken down the rock by explosives, if you try to visualize the situation, you're definitely gonna use diggers to remove the rock, right? And then when you're done with all of these things, you're gonna transport it, okay? Depending the word of stone and or sorry rock or mineral accordingly, okay? So if they're asking about the method of quarrying, the method is going to be the same, but in place of mineral you're going to have rock. But if they're talking about open cast mining, you'll have mineral in the place of rock, okay? Then moving on to the second type of mining that's in our syllabus, subsurface mining, we can say deep mining. Okay, now again, this has some steps that you need to write in chronological order. So if you talk about deep mining, it's done for minerals that are deep underground, right? So what you're going to do is, first of all, you're going to sink a vertical shaft, and following that, you're going to yes, quarrying and open cast mining both includes explosives. Tada. So if we talk about deep mining, we have the first idea that we're going to sink a vertical shaft, then we're going to make a horizontal tunnel following the mineral layer. Then we're going to extract the minerals. Then again, all of these the steps are same. That you're going to extract the minerals by diggers or by a machine. They're going to bring the loose rock out of the mine to the surface, pile it up in waste heaps, and then you're going to simply transport it. Okay. So if we talk about, if you compare both of these two types of mining, you definitely have the idea that deep mining is more dangerous, because if we talk about deep mining, in case of a flood or fire, it will definitely be more difficult to escape. And then you would have ventilation problems. There will be a high risk of fire because you have poisonous gases. Okay, so all of these things. And also, miners develop some problems because of um, inhaling minerals. For example, silicosis is a problem that occurs by inhaling quartz, okay, which is a mineral, okay? So all of these ideas tell you that yes, deep mining is definitely more dangerous than open cast mining, okay? Now moving on to the factors, yes, and we also had this, okay, so first of all, I had already discussed this factor yesterday, which was the idea of folding and faulting. So if we talk about folding, it's just simple folding, okay? So it's just simple folding of the mineral layer. So it will be definitely difficult to use machinery. And then if you talk about faulting is simply the idea that two mineral bearing layers are not on the same level as each other. Okay, the factors, you have five factors that you need to remember. First of all, we have five factors in our syllabus. We have geology, we have exploration, feasibility, depletion rate, location, supply and demand. So if we talk about geology, we have the simple idea of falling and faulting, okay? And then if you talk about exploration and feasibility, then we have the simple idea whether it's easy to look for minerals, whether it's difficult to look for minerals, whether that area doesn't has local environmental issues. Okay, and then if you talk about depletion rate, again, we have the idea that if you want to mine a mineral, it should be economically worthwhile, right? So for example, if you are spending all those resources on mining a small reserve, it's not going to be economically worthwhile, okay? So that is why we want depletion rate to be less, right? So again, large deposits and plentiful reserves remain. Many good quality deposits, easy to mine, are still present. Then if we talk about location, we just have two factors, climate and transport. Of course, if you don't have extremes of weather like great heat, dense cold, or heavy rain, it's gonna be far more easier for you than working in these conditions, right? And then if you talk about transport, we already have the idea that after you have extracted minerals, you have to transport it. So if the infrastructure is already developed, we have roads and railways, then it's gonna cost the mining company less because it wouldn't have to start from scratch, right? It already has a dense network of roads and railways, right? So for example, in the Amazon rainforest, we have the idea that it's rich in iron ore and other minerals, right? But the road network is not developed, right? So why are they still going towards mining the reserve? Because the fact is that large deposits remain there, right? But still, the disadvantage of doing mining in Amazon rainforest is that the infrastructure is not feasible, right? So what they're eventually doing, they're doing deforestation to overcome that. Okay, next let's move on. And then you have this simple factor of supply and demand. What's going to happen in it is basically that even if you have supply, is basically the amount of resource that you have, right? So even if you have a small amount of resource, but the demand is high, that means that even that small amount of resource is going to be really valuable, right? So it's going to have a high price. So even small mines that are which would not have such a big advantage in terms of money, in terms of spending on that mine, they're still going to invest because they know that prices are high, right? So but if you talk about a scenario in which the demand is low, then definitely prices are going to decline, so it will not be economically worthwhile for a mining company to go towards mining until and unless it's very strong financially, right? So yeah, the simple idea of supply and demand here, try to remember it this way: whenever you have low supply, you have high demand, and low demand, supply high, right? And then you have this picture showing you how an open cast mine actually looks like. Whenever you'll have a large hole in the ground, that's always going to be open cast mining, okay? Until unless you don't see shafts, you're not going to go towards the idea of deep mining. Now let's move on. So this is the third pointer. We covered two pointers of this chapter up till now. Now in the environmental, economic, and social impacts of rock and mineral extraction. So we have loss of habitat, noise, water, land, air, visual pollution, management of waste, employment opportunities, improvements in local national economy, improvements in facilities and infrastructure. So so let's start with positive ones first. So if you're talking about mining, definitely it's a source of employment, right? And if we talk about source of employment, unemployment is reduced. We have the idea that minerals have large high value in the world market, so we're going to earn foreign exchange through it. And then when a country is going to get foreign exchange, it can invest it to modernize infrastructure, to invest in development projects. Okay, so you have all these things. And then of course, this third pointer is that pointer which we were talking about, location. If you're talking about um, an area where you don't really have a dense network of roads, where you still have very large deposits as a mining company. And for example, if I'm talking about not a forest situation, but a rural area situation, right? And the mining company decides to mine that resource because we have very large deposit, right? So it's going to be a benefit for rural areas because they're going to develop the infrastructure because they want to transport the minerals, right? So this is the idea of the last three pointers. Now let's talk about them in detail. So first of all, If you talk about noise, air pollution, air visual pollution, we have the idea of using explosives, we have the idea of transport, right? We have the idea of crushing and refining of mineral ores. So all of these things are going to contribute to air and noise pollution, right? And visual pollution. So both open cast and surface mining lead to surface waste heaps. At best, these look unsightly and destroy the natural beauty of the area. Much worse, after periods of heavy rain, waste heaps become unstable and flow down, so destroying everything in their path and covering even larger areas of land. So first you have the idea that both surface mining and both open cast mining cause what? They lead to large waste heaps, right? So the idea that first of all the major problem is how are you going to dispose that waste, right? So that is the first problem. And then you have the second problem that in periods of heavy rain, those waste heaps are going to become unstable and they're going to destroy everything in their path when they're going to flow down slope, right? And then also when you are making new mines in remote areas, that's gonna lead to forest clearance, like I talked about Amazon rainforest. And whenever you're talking about forest clearance, whenever you're talking about deforestation, you have this simple idea that's going to result in loss of habitats, and thereby it's going to result in reductions in biodiversity as well. Then crushing and refining are again two processes from which we extract, by which we're able to extract the mineral from the ore. So that again is going to contribute to air pollution, right? And then when we talk about chimneys themselves, they themselves are a source of visual pollution, right? They're ugly simply. Okay, then if you talk about rivers and streams, now this is the idea of how water pollution is being caused, right? So rivers and streams are polluted by water flowing through old mine workings. We have the idea that when these water bodies are going to get polluted, they're going to have a high concentration of minerals, and because of that they're going to have shortage of oxygen, and the plants, the fish, and other water creatures are going to get killed because of that. And you also have the idea that we have toxic metals such as lead and mercury, and our organisms can consume it. For example, they may be absorbed by our plants, and then they're gonna travel up the food chain, right? And then you comes the idea of bioaccumulation and biomagnification. So bioaccumulation is a simple idea that a substance that cannot be excreted, for example, toxic metals like lead and mercury, is going to pass along the food chain, it's going to get accumulating in the organisms on the higher trophic levels, right? And until it's going to reach the top predator and prove to be lethal. Okay, lethal any type of mine. I'm reading from here. Water pollution from any type of mine can be a major problem that can continue for many years after a mine has stopped working. The water that drains through mine waste or comes directly from mine shafts can cause dramatic changes to the populations of living organisms in streams and rivers. Drinking water supplies may also be polluted by drainage from mines, making it unsafe for people to drink. Again, we also saw that photograph in which we saw that when the land becomes barren, surface runoff, the rate of surface runoff is going to increase, right? And eventually, surface runoff ends in rivers and may carry all those toxic metals along with it, and it's going to contaminate the water resources as well, right? Now, this pollution is caused by chemical reactions between water and exposed rocks and mineways. The water may become acidic and then dissolve toxic metal ions. The combination of acidic water with a high concentration of toxic metal ions kills many aquatic organisms. Some of the metal ions exist only in low concentrations in bodies of water. However, organisms absorb these ions and retain them in their body, right? So, reaching concentrations much higher than that in the water. This is called bioaccumulation. The concentrations increase further in organisms that are higher up the food chain. This process is called biomagnification. So, usually don't really ask you in detail, but you have to have the idea of how bioaccumulation is a process by which you need to give the idea. Remember, you will be given marks on giving the idea that because the toxic metal is not excreted, that is why it's retained, right? So take Amata mine. This is the largest open cast mine in the Atacama Desert of northern Chile. Just a fact. And then you have the idea of impacts on people. So of course we already talked about this, right? We know that miners are going to work. So if we talk about negative impact, impact is mainly on miners, right? But if you talk about that, if and we discussed all those problems, we had breathing and chest problems, silicosis, ventilation problems, risk of fire, flood. Okay, but then if you ask the question that why are miners going towards mining if it's such a difficult job, right? So the idea is that because it's an unskilled form of work, and then you have probably a desert coast where other sources of income are not, there is not a variety of earning of different sources of income. For example, if you talk about Peru, we call Peru a desert coast, right? Why? Because only the major source of income in Peru is fishing. The greatest example for mining is South Africa, right? So South Africa, we have gold and diamond mines, right? Now, if you talk about economic benefits, another factor here is that you have economic benefits because you have the idea of foreign exchange, and foreign exchange is invested to modernize infrastructure and improve people's quality of life. Then you have open cast mining. Again, you have the idea of waste heaps, you have the idea of visual pollution, you have the idea of loss of habitats, increased surface runoff, explosives. So, if we talk about the case study with it, Cerro de Pasco, remember we had cracks in the houses, right, because of the idea that they were using explosives, right? Now, this is the definition of economy, the state of a country or region in terms of the production and consumption of goods and services and the supply of money. So again, if we're talking about consumption of goods and services, you have the idea that minerals, definitely they can be used to make many products, many goods, and minerals can themselves be exported as well, right? For example, yesterday we were talking about uranium, right, and how only three countries had resources of uranium. So the country can fix the price according to its own need because countries, right? So it can again take benefit of export. And then we also have that idea which I just discussed to fund development projects, modernize the infrastructure, improve people's quality of life. Then if you talk about infrastructure, it is basically the facilities and services needed for economic development. Okay, so we were on discussing what is infrastructure. Infrastructure is basically the facilities and services needed for economic development. And remember, whenever you're talking about infrastructure in your answers, try to give an example, one or two examples that it may help to develop infrastructure. For example, roads, railways, sewage works, water supply. Just give any two examples, right? That will really help. Then case study examples to consider. We have construction of roads for Amazon Basin in Brazil and Peru. This is Amazon Basin. Then drilling rights for oil and gas granted in Kirtan National Park in Pakistan. So these are the wrong scenarios that are happening in our world nowadays, right? And this is Tasman's Spirit disaster. It happened in Arabian Sea in Pakistan, and this is Amazon Basin, and this is the largest open cast mine. Okay, this is Cerro de Pasco, right? And then why does government provide mining authority to companies despite its negative impacts? Because again, mining is a source of foreign exchange income, thereby government receives huge amounts of taxes, which it can use to provide pensions, modernize infrastructure, and improve people's quality of life. Okay. So this was okay. So describe and evaluate strategies for restoring landscapes damaged by rock and mineral extraction. So you have a few techniques on how you can handle the waste, how you can handle the quarry left the large hole left in the ground after mining. So first thing is landfill, right? So it's again that abandoned quarries or large holes left in the ground as a result of mining can be used to dispose waste, right? And then you have the simple idea that you need to remember this because of course in every paper we can be asked anything, right? And we can be asked a few new things, right? So you need to remember it for 2 points, that you have the idea that the waste is dumped into holes and then it's leveled off and compacted by bulldozers, right? And then of course if we talk about the advantages, large amounts of waste can be dumped cheap and easy way. But however, we also have certain disadvantages because of which we're going to come to an idea called sanitary landfill, right? So we have the idea of land contamination because waste includes dangerous substances and they may leak into the ground, right, and contaminate water resources. And then you have the idea of health hazards because, of course, we're talking about large heaps of waste being dumped into holes. So you're going to have various mouses, like rodents are basically species of mouse, right? So you're going to have flies, foul odors from the presence of harmful substances. Right, and then you move on to the idea of sanitary landfills. That to overcome these problems, what we can do is we can do waste disposal. We can practice a waste disposal technique which we call sanitary landfill. So how does sanitary landfill help us to overcome all these disadvantages? That basically we are placing alternate layers of refuse and soil. So you have basically the waste, and then you have a layer of soil, the waste, soil, right? And then the top layer of soil is going to prevent many health issues, right? And then we move on to bioremediation, in which we're simply gonna like a little bit like biological control, but the idea is that you're basically using natural organisms to remove pollutants in soil and water. But again, this is not going to be useful on toxic waste, right, such as lead. Then landscaping, remember we learned about two things. We learned about land reclamation. This thing provide recreational opportunities for people. This is land reclamation. But if you talk about making the mined land look like as it was before, mining, that is the idea of landscaping. And then when you're doing landscaping, you can go towards tree planting, because trees are going to bind the soil together. At this stage, we already know what are trees useful for. They're gonna increase interception, increase infiltration, reduce surface runoff, bind the soil together, contribute to humus formation, which again is gonna help retain moisture in the soil and keep it compact, and also that they're commercially profitable, right? Then we have the idea of how we're going to, okay, so this is all of the things we have discussed. This is a summary. I have already sent the drive link on the group, so when you're going to open these notes, you're already going to get all of this, right? So you can go through it on your own. It's the same thing I discussed, right? I got this from Google, that's why I placed it here. And these are some photographs for your reference. And now this is again, if you're thinking about landfill and you're wondering that why is it that it has so many disadvantages. You have a hole and you're simply um, filling it with waste, and you're simply leveling it off and compacting it by bulldozers. No, that is not the actual idea behind landfill. This is how a landfill looks like, and that is why you have the idea of those many disadvantages, right? So next, this is the Eden project, right? If you go back, there was one pointer in about nature reserves, right? Wetland sites, nature reserves, right? So what happened was that this was an abandoned quarry. This is called the Eden project in Cornwall, England, right? And what happened was, what they did was, it's basically a case study that you can again go through that blurry book we have, right? So in that, what they did was that basically had an abandoned quarry, and they built nature reserves in it. And these dome shaped things you can see here, this is basically a greenhouse or glass house, right? And we have greenhouses, glass houses, because we're maintaining certain climatic conditions, because we're replicating the biomes of African savanna, right? So this is the idea behind this. Like it's basically a very wonderful way how you can how you can reclaim land that was previously destroyed by mining, right? Next, we are moving on. Okay, so this is finally the last pointer of the syllabus. After every chapter, you have the idea of sustainable development. And in this chapter, you will also be introduced to what sustainable development is, right? So when you're talking about sustainable development, you have the simple idea that's fulfilling the needs of the present generation, it's fulfilling the needs of the future generation, and it's protecting the environment as well, right? Like basically the idea that people are working along with the environment, right? So we have activities, we have economic growth, but the environment is also something that is to be taken care of. Okay, now how are you going to, and then okay, now once you know what is sustainable resource, what is sustainable development, you're gonna move towards how you're gonna bring sustainable development in this sector of mining, right? So you have again four strategies, and again I'm gonna emphasize that try to write it in the same words like it's written in the syllabus. So the increased efficiency of the extraction of rocks and minerals. Now again, if you're talking about increased efficiency, you're talking about better technology. So if you have better technology, you'll be able to extract more of the mineral from the ore, right? We don't have mineral unless in original form, until and unless it's very pure. For example, gold, it's formed naturally. It does not has to be refined, right? But if we talk about several other minerals, most of the minerals are found as part of ores, right? For example, the bore of aluminum is bauxite, right? So, you have the idea that if you're going to have better technology, you will be able to extract more of the mineral from the ore. And definitely, if from a certain amount of ore, you're able to extract more of the mineral, you are going to increase the life expectancy of that mineral as well, right? Of the mineral reserve as well, because you have the amount required that you need, right? So, you're not going to go towards more mining, right? For example, I think we even did a question in which the idea was that they were mining and they couldn't find more minerals, so they went towards expanding the mine, right? And the idea was that there was very less copper in that ore, right? So because I'm gonna speak a little low because Azan is going on, So the idea was that in that ore there was very little copper, only 1% copper. So they went towards expanding the mine, right? And definitely, if they're expanding the mine, they are reducing the life expectancy of that mineral, right? Then we have increased efficiency of the use of rocks and minerals. Now, this idea focuses on the research and development departments of several mining companies. They can basically, for example, if you talk about oil and natural gas, they are also minerals, right? And gold, right? So if you talk about these things, they're also minerals, right? So the idea is that you can make you can develop engines. I'm giving some examples of how you can increase efficiency in use. You can, for example, develop engines that can travel more kilometers in less amount of fuel, right? So that is how you're going to bring efficiency in the use of rocks and minerals. And remember, I am that developing engines which can travel more kilometers in less amount of fuel, or you can have that placing placing tags on our electrical devices which show how energy efficient that particular device is or that particular product is, right? Or appliances. And then of course we have the simple idea that we can switch off lights and electric appliances and whatever, all of those things that consume electricity when not in use, right? So this is all about the strategy of how you're going to bring efficiency in the use of rocks and minerals. Then the need to recycle rocks and minerals. So again, this pointer is also related to increasing the life expectancy of the mineral, because of the idea that you're recycling it, right? Which means that you can, for example, melt down the aluminum cans and you can develop them into a different product, right? That's definitely gonna reduce the demand for extracting more aluminum, right? Then moving, know that there are three R's, right? We have reduce, recycle, and reuse. Then if you talk about, for example, plastic bottles, we can again reuse them, fill them with water. Now, why am I talking about plastic bottles here? Because of the idea that if you talk about manufacturing water bottles, that requires electricity, right? And electricity comes from fossil fuels. And fossil idea of legislation is a simple idea that government enforces the rules and regulations, right? So if you have rules and regulations but they're not being enforced, it's not gonna be useful, right? So the government should take action and it should have strict rules and regulations. It can provide, and of course legislation is not only about fining or putting fines or taking high taxes so that mining company can carry out safe disposal techniques or follow the rules and regulations. It also involves that the government can provide incentives to those mining companies which are actually following the idea of sustainable development, right? So this was it for this chapter.